countdown.
Congratulations! This live broadcast is specially brought to you by Academy YouTuber Malaysia, an initiative by eDidik Malaysia and Kelab Guru Malaysia. Please pay attention. The live broadcast will begin shortly. The link to the certificate of attendance will be provided at the end of the session. Please make sure it is filled within the stipulated time. Thank you.
Okay. Hi everyone. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi taala wabarakatuh and good evening to all teachers, parents and the wonderful student. Welcome to Pusat Tuisyen YouTuber, a joint venture with eDidik Malaysia and Kelab Guru Malaysia. With the hashtag Bermula Percuma, Selamanya Percuma. So before we proceed, let's begin our session with the recitation of the Kitab, Al-Fatihah for the Muslim and moment of silence for the non-Muslim. Al-Fatihah. Okay, so how's everyone today? My prayer that everyone in is in the best of health and ready to proceed with today's class. So before we start, let me introduce myself first. My name is Nun binti Muhammad Nur. You can call me Madam Nun. I am a lecturer from College Matrikulasi Negeri Sembilan, and I am your moderator for today's class. So the most important person today is our passionate, fantastic presenter, Madam Rosmaya. Okay, she is a very experienced teacher from SMJK Yuhua Kajan Selangor. So let us give a warm welcome to our presenter. For the record, we are now live on Madam Rosmaya channel. So as a sign of support to Madam Rosmaya for the hard work in preparing today's lesson, please subscribe her channel. As usual, the lesson will approximately 1 hour. The certificate link and the credit claim link will be given at the end of this session. So remember that you can only use the email to claim the certificate. For the credit claim, you need to collect the one letter and 5-digit code with which will be announced separately during our class today. So be sure to follow the class until the end to get the complete code for the credit claim. I would also like to remind students, if you wish to post any comment in the chat box, please use appropriate language and use appropriate profile picture. I am pretty sure all students here are excellent students who will uphold a positive classroom environment. Please give your full cooperation in making this class a lively one. Stay focused, and if you have any question, please write on the chat box and we will try to provide you with the answer. So before I give Madam Rosmaya to present, I will announce the first digit code for the the first letter and 2-digit code for today's class. Okay, so the first letter and the 2-digit code is A23. Okay, A23. Okay, A23. So without further ado, please welcome Madam Rosmaya to start her presentation. Okay, Madam Rosmaya.
Okay, thank you to the moderator, Cikgu Non. Okay, so Assalamualaikum and good evening everyone. Okay, I can see there in the chat box, Chia Yao. Okay, thank you, Chia Yao. Okay, so okay, my PowerPoint is there already. So I am Madam Rosmaya. I will guide you all through this live session. Okay, on the topic geometrical optics and wave optics. Okay, so we are going to solve about 10 questions, okay, given earlier already down in the description part below and also in the comment. Before we start, I'm going to introduce the pre-U team in Academy YouTuber. Okay, so this is physics team led by me. Okay, I'm Madam Rosmaya, and our member is here. One of the member is Cikgu Non. Okay, and we also have Teacher Sue and Teacher Non. And then biology pre-U, okay, led by Cikgu Faiza. We have also chemistry pre-U led by Cikgu Shahnun. So today we take her time for physics class because they are in holiday fasting during fasting month. Okay, happy fasting for today. Okay, next is mathematics lead by teacher Im, mathematics T. Okay, we also have perakaunan and economy. Okay, pre-U lead by Madam Fizi. Okay. And Academy YouTuber also have apps. Okay, you can download from the Google Play Store. Okay, there are also physics, a lot of physics video, PDPC video there. Okay, including our live session also. You can search there for your to repeat. Maybe to repeat the you're watching in the apps here. Okay, so next, now we are going to our main topic today. Main objective today is to solve questions. Okay, we do revisions on the geometrical optics and waves optics. Okay, so we go straight to the first question. Okay, we read the question. The diagram below shows two thin lenses, L1 and L2, okay, which are placed coaxially at a distance 30 centimeter apart. So each lens has a focal length of 40 centimeter. So if the incident ray to L1 are parallel, okay, drawn here, the final image which is produced after ray pass through lenses L1 and L2, okay, is, okay, that given here the answer A, B, C, D. So which one? So this is the characteristic of the image, and also the question asks for the location of the final image. Okay, so how to solve this question? Hopefully you all done the question because I give this question earlier, okay, already. Okay, the formula we are going to use is 1 per U plus 1 per V equals to 1 per F. Okay, and we have two types of lens, okay, concave and convex lens, or diverging lens and converging lens. Okay, this is converging lens, this is diverging lens. Okay, so the focal point is 40 centimeter, okay, for the convex lens, and for the concave lens is negative 40 centimeter. Okay, so the incident rays here is parallel. So this means that the object distance is infinity. Okay, then what else given? Okay, so for object that is at infinity, so it is understood that the image will be formed, okay, at the focal point, okay, which is F1 given 40 centimeter. So it is understood that when object is at infinity, so the image will be formed at 40 centimeter. So this is the hidden information we can get. Or if you substitute into the equation here also, so you still get B1 40 centimeter. But for during the exam, you can, if you understood, so very fast, you can easily get B1 without substituting the values here into the equation. Okay, so we are going to find V2. So V2, to find V2 for the second concave lens, okay, so we need to determine the U2, okay, U2. So we know that V1 is 40 centimeter, so it beyond this distance, 30 centimeter between L1 and L2. So 40 centimeter is beyond this 30 centimeter. So that means the distance here will be 10 centimeter. And the object distance will be negative. Why? Because it actually not there. The image is not there. Now it's become object for our second calculation. We forget about the convex for a while. So just concentrate on the concave lens here. So the image now become the object for the second calculation, and it's negative because the object is not supposed to be there. Okay. Okay, so now we substitute the U2 negative 10, and then the F is negative 40 because it's a concave lens. Okay, now we can solve for V2. and we get the value positive. So what does this means? Positive. So positive means it occur here, the same position here with the object just now, at negative 10 centimeter. Okay, so it's a real image. Okay, another one why we got positive is a real image. Okay, okay, somewhere there lah, because it's 13, right? So the object is 10. So 13 means further from here. Okay, there's a 13.3 centimeter there. Okay, so therefore the answer is D. It's real image. We got positive and located at the right side of L2. So this is concave lens L2. So it is located on the right side. Okay, so that's the answer. Okay, so hopefully you got the answer correct. So if you got the answer correct, you can write there in the chat box, to show that you understood the question. Okay. Okay, then I can give you all a clap. Okay, now we go to question 2. Chaya, okay, I give Chaya a clap lah. Cikgu Nun. Okay, so now we go to the next question. Question 2. Okay, question 2. Determine the focal length of the lens given below. Okay. So what kind of lens is it? It doesn't mention, but you know the shape, how to know the lens here has two kind of radius. Okay, so radius 12 centimeter. Okay, on this side, and then on the left side is radius is 20 centimeter. So the lens is made of from high index plastic of refractive index 1.72. So we are going to find the focal length of the lens. So here are the answers. Okay, which one is the correct one? So we use the formula lens maker equation. Okay, lens maker equation. So we are going to determine this focal length of the lens. So lens maker equation is 1 per f. F is focal length equals to bracket n minus 1 and then times the other bracket 1 per R1 plus 1 per R2. Okay, so the formula here we use plus. If you refer to different book, maybe here written as negative. Both are correct actually. It depends on how you define the R actually. How you define the R. Okay, so for my students, I use this formula. Okay, plus here. Okay. So how to define this R for this formula plus? So we define R. Okay, for the concave here, the curve here is concave curve. So the radius is negative. Okay, negative R1. So we name this as R1. So usually R1 we give for the incoming light. Incoming light, the side with incoming light, R1. Okay, for the if it is a concave curve, okay, this side, so it will be negative. So here is negative R1. Okay, next for the other side of the curve, okay, is positive because it's a convex. Okay, convex. Okay, so the side with outgoing light usually we name as R2. Okay, so now the label for R1 is negative and R2 is positive for this formula plus. So we use this definition for the sign of R. Okay, so now we are going, N is given. Okay, now we have everything. So you substitute into the equation here. Okay, we substitute into the equation here and we get F a negative 41.7 centimeter. So what is negative means? So it means that the lens, this lens is a diverging lens or concave lens. Okay, so that's the answer A. Okay, negative 41.7. Okay, because our answer here is negative, so that's mean the answer here, the type of lens here is a diverging lens. Okay, Chia, yeah, the answer is A. Okay, you can write there. Okay, so that everybody can have a look with your answer. Okay, so now we go to the next question. Okay. Okay. Another way. Okay, and I give you tips here. Another way how to determine the lens given is a converging lens or a diverging lens. Another word is we use convex lens or concave lens. Okay, for converging lens, okay, how to know? The lens is thicker in the middle. Okay, thicker in the middle and thinner at the edge. Two edges here. Then this lens serves to converge light. But if the lens here is thinner across the middle here, okay, the middle here thinner, right? Then the other two ends is thicker, so that's mean this lens serves to diverge light. So this is tips on how to know. Okay. Besides you calculate the F first, like just now we calculate, we got negative. So the negative means it's the lens is the diverging lens. Okay. This is another method. So this is another method how to know the types of lens is whether it is converging lens or diverging lens. Okay, maybe it's probably can help you to check your answer. Who knows you get careless mistake somewhere. Okay, you can use these tips. Okay. Okay, so now we go to the next question. Question 3. Okay, question 3. A diffraction grating with 2,400 lines per centimeter is used to produce a diffraction pattern that is recorded by a detector. Okay, so the first order fringe is 8.94 centimeter from the central fringe. So if the distance between the grating and the detector is 0.625 meter, so what is the wavelength of the electromagnetic wave used? So what are the information given? You are given the number of lines per centimeter. Okay. Then you are given the first order. So that's mean the M equals to 1. Some books use N. Okay. And some books use M for the order. Okay, this 8.94 is the this fringe separation. Okay, fringe separations. Some books use X, some books use Y. So I use Y here, fringe separations. And then the distance between the grating and the detector or the screen. Okay, so this is capital letter D. Okay, 0.625 meter. Okay, so we are going to find lambda, the wavelength. So the formula we are going to use here is for diffraction grating, okay, we use m lambda equals to d sine theta, okay, with the order m, okay, the order m here. Okay, so D is the distance between the slits, okay, this is diffraction grating, so distance between the slit where we can calculate from the end here. Okay, number of lines per centimeter for the diffraction grating. Theta is the diffraction angle. This is theta. The wavelength and the order number for the maximum, M. Okay, so we substitute everything. First, we substitute the D. Calculation is 1 per N. Okay, 1 per N. So 1 per 2,400 lines per centimeter. So convert to meter. So per centimeter when bring up becomes 10 to the power of 2. So no negative there. Okay, so this is where student always make careless mistake. Okay, careless mistake here. The power here is 2 positive because this is per centimeter. So when you bring up, you get 10 to the power of 2. Okay, so centimeter convert to meter. Okay, now the M is 1. Okay, order, first order. Okay, so for the theta, okay, so observe from here. Okay, so this is the grating and this is the detector or where the screen is. So the distance is 0.2625 meter. Okay, in here given in centimeter, but in meter 0.2625 meter, and the separation of the fringe is 8.94 centimeter. Okay, so you can use trigonometric you can use Pythagoras theorem to find the angle. So here you can use Pythagoras theorem here to find here. So sine will be opposite per hypotenuse. Okay, trigonometric ratio. Okay, sine theta opposite is 8.94 and then per hypotenuse here. So the length here can use Pythagoras theorem. Okay, or you can use whatever method you know. Tangent, use trigonometric ratio, use tangent, or use tangent also can here to find the theta, then substitute into here also can. So it's up to you. But here I use a trigonometric ratio, and the distance here I use Pythagoras theorem. So the answer for wavelength is 590 nanometer. So I convert it to prefix form already. So the answer is B. Okay. What about you all there? Oops. You get same answer or not as my answer? Okay. So we go to the next question. Okay, now the thin film topics, subtopic for this question, thin film. Okay, question 4. Okay, a solar cell consists of silicon, okay, with a coating of silicon oxide. So it's shown in the diagram below. So we have silicon oxide on top, drawn here. Okay, this is silicon and this is silicon oxide. Okay, the monochromatic light is vertically on top of the silicon oxide. Okay, so if the refractive indices of silicon oxide are 3.50, okay, then the 2.0 respectively. Okay, what is the minimum thickness T of the coating so that monochromatic light of wavelength 600 nanometer is not reflected from the surface of the coating. So this is the coating. The light is incident here, okay, on the surface of the coating. Okay, so this is the answer. Which one? So we use the thin film equation. Okay, to know the equation, okay, we check how the light if reflected. Okay, the first light will reflected on the surface on the boundary of air and the silicon oxide here. Okay, and the path taken will be half lambda because this is reflection. So the path difference is half lambda. Okay, so this is the characteristic of the light when it's refracted from the less dense to a denser medium. So the path difference will be half lambda. Okay, then the path for the second one, okay, the light refract here through the boundary, the silicon oxide here, and then reflected again. Refract, and then reflect. Reflect. So the journey travel here, okay, in the silicon oxide. So the optical path taken is 2nt plus half lambda. Why plus half lambda? Because it is reflected. Again, here is from the less dense to denser, 3.50. So that means this is denser. The silicon is denser and the silicon oxide is less dense. So that's why we need to add the path half lambda. Okay, and then the 2nt is because the light travel in the medium here. Okay, double journey. See, from here to the boundary here and then up. So 2nt from the optical path length formula. Okay, remember nt? So double journey, so that's mean 2nt plus half lambda. Okay, so now the difference between these two, okay, these two lights, okay, will be path 2, okay, path difference 2 minus path difference 1. So 2nt plus half lambda minus this half lambda, so you get 2nt, okay, 2nt. So this is the formula for the to get the to get the what here, to get the minimum thickness for the case where not reflected from the surface. So if not reflected from the surface, so there are two possibility. So 2nt equals to m plus half lambda. Okay, this one is for the disruptive interference. For this case, not reflected. So another case is for the constructive. You equate this path difference equals to m lambda. Okay, this one is for the constructive interference. So what can be seen here? Okay, what can be seen here is not reflected. So it is understood that it is disruptive interference occur here. For the disruptive interference occur, so we equate the path difference as m plus half lambda. So this one we don't want. Okay, this one we don't want. So we want this one. Okay. Okay, the difference is by half lambda to get disruptive interference. Okay, understood from this this meaning. Okay, it's disruptive interference. Okay, so now it's time to substitute the value. Okay, so minimum thickness means that the m here is 0. Okay, we are going to save cost. We don't want the thickness take too much silicon oxide to be coated. To save cost, we want the minimum thickness. Okay, so the minimum thickness is when m equals to 0. So you substitute into here 0. Okay, half lambda given 600 nanometer, convert to meter. And the diffractive index for the coated, don't 3.50 is 2, because this is the we are going to find the thickness of the silicon oxide. So the refractive index n here will be 2. Okay, now we calculate the T, we get 7.5 times 10 to the power of negative 8 meter. Okay, so convert to nanometer because our answer here is in nanometer. So that means the answer is 75 nanometer. So the answer is B. Okay, so done. Hopefully you all understand. Okay, so now we go to the next question. Okay, so the case just now we discussed for the destructive interference. This one destructive interference for the glass to be, for the medium to be coated. Example glass. So 2nt. But I make this bigger. Okay. So this is what we discussed just now. Another possible question, they ask you if like in the air bubble. Okay, this is the, let's say the bubble. So air, the bubble and the air. Okay. So for the case where the no medium to be coated here. Okay, like example in the bubble. So the phase will be 2nt minus half lambda equals to the for destructive interference is m plus half lambda, and for the constructive interference is equals to m lambda. So you must know the difference between these two. Okay, these two cases. So our cases just now is this one. Okay, so there are many cases they can ask you. Example, another cases is maybe you want to coat the window or the sliding door, the spectacle. Like our case just now is a solar panel, right? So be careful, okay, between which one to be used, the equation. So this is the what you call that, conclusion, conclusion, okay, formula, okay, which one to be used. Okay, so done. Okay, for question 4. Okay, so next we discuss the question 5. Question 5 got 2 questions here. Okay, we read the question. A monochromatic light with frequency 6.0 times 10 to the 14 Hz is incident normally on the diffraction grating which has 3000 lines per millimeter. So determine the angle diffraction for second order maximum and determine the number of maximum produced. Okay, so you are given the frequency. So the you can get the D from the number of lines here. This is N, then you can get D from formula D equals to 1 per N. Okay, then you are going to find theta for the second order and number of maximum produced. Okay, so we do question 1 first. Okay, so the formula for diffraction grating, okay, we've used already this equation just now. D sine theta equals to m lambda Okay, so the order is 2 here, 2. Then the lambda and the D is 1 per n. So 300 lines per millimeter. This time per millimeter. So that's mean 1 per 300 times 10 to the power of 3, positive 3. Just in case you forgot in the exam, you can use ratio method. Okay, like this. 300 lines means 1 millimeter, convert to meter. So for 1 lines is, we don't know D. So you just use the ratio to get this one. So very simple. To avoid careless mistake lah, you can use this method. This is just the maths you've learned in secondary school. Okay. Okay, now the wavelength. Okay, for the wavelength, you can use V equals to F lambda. So monochromatic light has speed C, speed of light. So frequency given here. So you can use lambda equals to C per F to find the wavelength. Okay, so substitute the frequency here. Speed of the light is 3 times 10 to the power of 8 meter per second, and you get the wavelength. Okay, so now you get the answer, angle 17.5 degrees. Okay, so next question is question 2. Okay, for question 2, determine the number of maximum produce. Okay, so you use the same equation, formula, d sine theta equals to m lambda, but to find the number of maximum produce, that's mean the bright fringe, maximum is the bright fringe, how many there? So we need to find the m first, the order. Okay, so the order of maximum. So we need to find m first. So the for the maximum number, so it is understood that the angle is 90 degrees maximum. So sine 90 degrees is equals to 1. Okay. So D is the same as the above because it's the same diffraction grating, and the wavelength also is the same. So you find M. Okay. So the sine theta is equals to 1. So you cross multiply here, you get M 6.7. So your answer must less than 6.7. Don't round it off to 7 because it's not logic for the angle to be larger than 90 degrees. So the light won't be able to pass through the diffraction. So it's not logic. Okay, think of the logic. So it must be less than 6.7. So therefore, the answer is 6. This is where students make careless mistake by rounding it off to 7. Okay, it's not 7, but it's 6. Okay, be careful with these types of question. Okay, have we come to the answer yet? Not yet. You be careful with the question. The question asks for the number of maximum produce. Okay, so to help you imagine how the number of maximum produce. Okay, the M just now, the order is 6. So that's mean the center here 0. So that's mean 1, 2, 3, 1, 2 on top here. There are 6. 6 more on top. And this is a top view. And then bottom here, we have also negative 1 to negative 6. So what does that mean? So that mean the total will be 6 plus 6, top and bottom, 6 plus 6. Don't forget to include the M equals to 0 order. Don't forget. Many students forget this one. So 6 plus 6 plus 1. So all together, there are 16 number of maximum produced. Okay? So don't stop there. Your answer, don't stop there. Must really understand what the question wants. The question wants number of maximum produce. So the number of maximum produce is 13. Okay, be careful everyone. Okay.
Okay, Madam Rosmaya. Before we proceed to the next question, can we take a break for a while?
Okay, we take a break.
Okay, everyone, let's watch the advertisement.
Stay tuned.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay, everyone, welcome back. So, I will announce the second digit code, the third digit code actually for the credit claim. So, please listen carefully. The third digit code is number 6. Okay, the third digit code is number 6. All right, now, Madam Rosmaya, you may proceed with your presentation. Thank you.
Okay, thank you, Cikgu Non. Okay, so Chia Yao there, the answer for number 2, 13 make correction there, it's not a 6, okay, it's 13. Okay, so now we continue with question 6. Okay, question 6, we read the question. The diagram below shows the lens of a student's spectacles, which is made of glass of refractive index 1.57, and the lens surfaces have radius of curvature 15 centimeter and 13 centimeter respectively. So determine the focal length of the lens and then state whether the lens is of the converging or diverging type. Okay, so then the question B, student wears the spectacles and dives in the water of refractive index 1.33 to see an object in the water. So explain quantitatively why the student is unable to see the object in the water clearly. Okay, so we do question A first. Okay. So this question, okay, they didn't mention which side has the radius, which side, like the first question we do about a similar question, okay, but this time it doesn't give you, okay, it gives you n, but the radius is 15 centimeter and 30 centimeter. So which side has which radius? Which side has which radius of curvature? Okay, so the radius here is radius of curvature. There are two. Okay, so how to know? I give you tips how to know. Okay, so imagine the curve here form a circle. Okay, form a circle, and the outside this one also form a circle. So which one is the larger circle? So the larger circle will give you the larger radius of curvature. Very simple to determine which side has which radius of curvature. So the larger one will be 15 centimeter and the smaller circle form will be radius of curvature will be 13 centimeter. And how to know which one is positive and negative? Okay, so remember I give you tips to memorize. Okay, for convex, R2 will be positive. This is convex side. And for the concave side will be negative. Okay, because we are going to use the formula. Okay, can memorize the formula by right now. You must memorize already because in next week or the other 2 weeks you will sit for the exam already. So you must memorize the formula already. STPM formula not given. So this we are going to find the F. So the formula for the F we are going to use. This is another question. Converging or diverging. Okay. So for the question, for the formula, we use Lensmaker equation. Okay, 1 per F equals to bracket and minus 1. Formula 1 per R1 plus 1 per R2. Okay, because we use this sign just now as I mentioned. So we use the formula here plus. Okay, so substitute everything together with the sign. Refractive index is 1.57. So you get the answer negative 171 centimeter. So the negative value shown, which one? Converging or diverging lens? If negative, so that means the lens here, which type? Is a diverging. Okay, diverging. Or to check your answer, who knows, you do careless mistake in the while you calculate. So you just refer to the tips I give you. Okay, so the thinner in the middle here. Okay, and thicker at the outside, at the edge, at the two edges. So that means this is diverging lens. So this might help you to get to check your answer, final answer. The question asks this state whether. So that means you need to do the calculation first, and then state it from your calculation. So this is the answer, diverging lens. Okay, so we keep the answer here because we are going to do B question. We clear this area. Now we do B. Okay, so now the student wears the spectacles and dive in the water of refractive index 1.33 to see an object in the water. So explain quantitatively. So that means you need to do calculation. Okay, quantitatively means you need to do calculation to explain your answer why the student not able to see clearly in the water. So for calculation, you use the formula 1 per F equals 2. So we have 2 refractive index, now 2 medium. So N2 per N1. The lens maker equation is where the N1 is equals to 1 because it's in the air, right? The spectacle used in the air, but if in the water, so we use this formula instead. So N2 per N1 minus 1. So bracket 1 per R1 plus 1 per R2. Okay, so now you substitute N2 1.57 and the medium, outside medium around the spectacle now is no longer air but it's 1.33 N1. Okay, so R1 and R2 is the same. Okay, so you get F also negative. Negative 5,500 centimeter. So the value is increasing and it's changed. It changed. Okay, so that's why the student is unable to see the object in the water clearly because of the focal length of the spectacle changes. Okay, so this is how you answer this question. Okay, explain quantitatively. So must do calculation, and from your calculation, so you explain. Okay, so there is a changes in the focal length. So how it change is increases. Okay, to 4,000 centimeter from 1,771 sorry, 171 centimeter to 540 centimeter. Okay. Okay, so now we go to the next question. Okay, question 7. A glass rod of 50 centimeter long has convex ends with radii of curvature. Okay, R1 equals to 5 centimeter and R2 is 4 centimeter respectively. Okay, so this side is 5 centimeter. The other side, the radius of curvature is 4 centimeter. Okay, so the refractive index of the glass rod is 1.40. Okay, the glass rod here has refractive index 1.40. An object at a distance of 30 centimeter from the X end of the glass rod is shown in the diagram below. So here, the X side here. So 30 centimeter, the object is here. So we are going to find the image position when object O is observed from the Y end side of the glass rod. So observe here. So what is the image position? And then draw the ray diagram. Okay, draw the ray diagram. Okay, so what's formula we are going to use? So the length of the glass rod here might help you to determine the object distance and image distance. Okay, this one might help you to determine the object distance and the image distance. Okay, this is R1, R2, and this is N. Okay, labeling like this might help you to reduce careless mistake. And then this 130 is the object distance. Okay, first object distance you want. We are going to find V, the image distance. Okay, so the formula is for the curved surface, okay, the formula is N1 per U plus N2 per V equals to N2 tilde N1 per R. So tilde means this value larger minus smaller value, larger value minus smaller value. That's why tilde, okay. So the formula is this one, and for the first image, this is in air. The object is in air, so the n is 1. Okay, u is 30 centimeter. Object distance here, 30 centimeter. So substitute into here, and radius of curvature is positive. Okay, because this is convex. This is convex curve. Okay, and then the object is in the less dense position. Less dense, and this one is denser. Less dense to denser, so that's why R1 is positive. So you must determine the sign also for the R. Okay, so now and then N2 is 1.4. So this one 1.4 minus 1, so larger minus smaller value. Okay, so the answer is 30 centimeter. So this 30 centimeter is positive. So positive means the image form inside the glass rod here. 30 means the image form inside the glass rod here. Okay, so we can draw first. Okay, for the first image, this first image. So the object, okay, somewhere here, 30 centimeter, not reaching beyond this glass rod because the glass rod is 50 centimeter long, 50 centimeter long. So 30 centimeter here to here. So this is the first image. Okay, 50 centimeter, so 30 centimeter, 20 centimeter from the other NY. So this might help you to determine the object distance for the second image. For the second image. So this is the first image. Okay, now for the second image will be object distance will be 20 centimeter. Okay, 20 centimeter, and it is positive. Why? Because the image is real. Okay, the image is real, and it becomes object now for the second surface. Okay, for the second refraction surface. So it's positive. Okay, V2 is the second image you are going to find. Okay, the R here is positive 4 here given 4, R2 is 4, and it is positive because the image here is on the concave side, but concave supposed to be negative, right? The 4 here supposed to be negative, but the object now, which is image from the first situation, it's in the denser medium. So if it in the denser medium, so you change the negative to back to positive. So you must very careful with the sign here. Okay, this one is not negative, because the object just now, this one, the object here is in the denser surface. That's why it's positive, even though even though it's facing the concave surface. Okay, so now the calculation. Okay, these two, okay, substitute here. Then you get V2 positive 33.3 centimeter. So positive means the image is on the other side. So the light travel, think logic also. When the light travel from here to here, it is refracted. And then for the second refraction surface also, it will be refracted, right? So the image somewhere here now, the final image. So it's 33.3 centimeter. So that's mean another 33.3 centimeter from the NY here. So this is the ray diagram lah. The ray diagram you need to draw. Okay, make sure you draw this line is a straight line. Okay, don't bend. Okay, don't. Another word is these two red and blue line is a collinear. Okay, collinear. Because the light travels straight to the medium. Okay, it's the same medium, so you must draw a straight line. Use ruler. In the exam, bring ruler. Okay, with you all. Okay, to draw a straight line must use ruler. Okay, so done for the question 7. So we go to question 8. Okay, the figure shows a beam of unpolarized light directed along the axis through polaroids P1, P2, P3. Okay, 3 polaroids. The polarizing axis of each polaroid is as shown by an arrow. Okay, here. polarites P1 and P2 are fixed. Okay, and P3 is set with its polarizing axis at a variable angle theta to that of P1. So the theta here, okay, for P3, polarite P3 is measured from the vertical here, referring to the P1. Here is a reference point of the theta, measured from vertical. Okay, so now the question asks, for what values of theta do intensity of the emergent beam from P3 minimum? We want the minimum. Okay, emergent beam from here, P3. Okay, this is the P3. Okay, so which one? There are two answers here. Okay, so why two answers? Okay, you must know that for minimum to the intensity, the minimum is when the first polarite and second polarite, okay, are arranged 90 degrees with each other. Okay, 90 degrees with each other. Okay, 90 degrees with each other. So the angle here must be changed to 90 degrees, okay, for the minimum intensity. Okay, so let's start now. Observing from here, okay, observing from here. So this is the P3, okay, this is the P3. Okay, the measurement of theta is from vertical, P1 as a reference, okay, from the vertical, and P2 is fixed, so 30 degrees here is fixed. Okay, this one is from P2. Okay, now to get the minimum intensity, so that means you need to rotate the polarite here another 90 degrees. Okay, you need to rotate it another 90 degrees, okay, for minimum. So that means altogether, the angle will be 30 plus 90 because the question asks to that P1, angle theta to that of P1. So that's why 30 plus 90, so you get 120 degrees. Okay? So that's the first one, but actually you get the answer already, D. But for the 300, how you get it? You get it? How? So you can also rotate it on the other side, anti-clockwise, right? This is clockwise, so you can also rotate it 90 degrees anti-clockwise. So that means the angle here 60 plus 30, 90 degrees. So you measured from the vertical, okay, clockwise direction. So that means 360 minus this 60. So you get 300 degrees. Very simple, right? So this is how you measure the angle by reference from P1. Okay, by reference from P1 here. So that's why the answer is D, 120 degrees to 300, another one is 300 degrees. Okay or not? Okay. Okay, so now we go to the next question, question 9. Okay, so we read the question first. Okay, this question is about fiber optic. Okay, one of the subtopic in our geometrical optic and wave optic. Okay, the speed of light along the core of an optical fiber is 1.57 times 10 to the power of 8 meter per second, and along the cladding is 1.67 times 10 to the power of 8 meter per second. Okay, so this is the cladding, this is the core of the fiber optic, and the plastic coating to strengthen the cladding and the core. Okay, to strengthen the cladding and the core. The basic fiber optic is only cladding and the core. Okay, so what is the minimum angle of incidence of the light in the core for it to be totally internal reflected? Okay. Okay, I think Form 5 the topic is in Form 5 already for the new KSSM syllabus. Okay, so STPM also learn this topic. Okay, so this is the optical fiber viewed from here, side view. Okay, viewed from here. So this is the cross sectional. This is the core, and this is the cladding. This is the cladding, and this is the core. So the question asks incidence of light in the core. So we just refer to the core. Okay, this part only, the core. So this is the core, and this is the cladding. So we want for totally internal reflected. So that's mean the angle here is the refracted angle will be 90 degrees. Okay, here the R here 90 degrees. So what is the theta here? So that it's R, right? The angle of refraction is 90 degrees. Okay, where total internal reflection starting to occur. Okay, so we are going to use the formula N equals to C per V. Okay, speed of light per speed of the light in the medium. Okay, V. Okay, we are going to use from the Snell's law. Okay, and we derive, we get N1 sine I1 per equals to N2 sine R. Okay, so this is N1, N2. Okay. So this is the formula, the two formula we're going to use. So we arrange this equation. So we get sine I per sine R equals to N2 per N1. The medium here, N2 per N1. Okay, we rearrange this equation, we get this. Okay, so now we are going to find I. So the R is 90 degrees, okay, because total internal reflection to occur, R is 90 degrees starting this point. Okay, so sine I per sine 90. And then the N for medium N2 will be C per V2. Okay, then for medium 1 will be N1 will be C per V1. Okay, so the C cancel out. So we get V1 per V2. Okay, V1 per V2. Okay, so now substitute 1.57 per 1.67. 1.57 times 10 to the power of 8 is from the core. So V1 is from the core. This is the core. So be careful whatever value you substitute. So V1 is from the core. Okay, 10 to the power 8, I didn't put because it cancel out. Okay, can be cancelled out. You can put here also, cancel out already. Okay, I didn't put so means cancel out already. So the answer I is 70 degrees. Okay, cheer Okay, so answered already you. The answer correct, 70 degrees. Okay. Okay, now we go to question 10, okay. The last question. Okay, fringe of separations Y are observed in a plane 1 meter from a Young's double slit arrangement illuminated by yellow light of wavelength 600 nanometer. At what distance from the slits would fringe of the same separation Y be observed when using blue light of wavelength 400 nanometer? So what are given here? Okay, the formula, memorize the formula here. Lambda equals to AY per D, wavelength. So A is the separation of the separation of the slit, double slit. So Y is the fringe separation. So this one is Y. And then D is the distance from the screen, okay? Slit to the screen. Okay, so now the changes is the changes is a lambda wavelength 600 nanometer to 400. Okay, so the changes is in lambda and the changes also is in distance. The plane is 1 meter from the slit. So we are going to find the new distance, D, capital letter D. So A and Y is constant. Okay, the slit remain constant, the separation slit remain constant, A, and the separation fringe also remain constant, Y. Okay, so that means lambda is inversely proportional to D. Okay, so we are going to use this relationship. So from the topic variations you've learned before in secondary school, so that's mean we can form the formula here. So from here, inversely means if the wavelength increases, wavelength decreases here 400, compare this 600 and 400. So that means decreases. If the lambda decreases, D increases. So it must larger than 1 meter. It must larger than 1 meter. So if larger than 1 meter, the answer is, the probable answer is C and D. Okay, A and B out already. Okay, A and B out already because 0.67, 0.33 out already. The answer is out already. Okay, so C, the answer is now whether C or D. Okay, so we form the equations here. Okay, because it is inversely, so the equations become lambda 1 per lambda 2 equals to D2 per D1. So just use the Bryson topic you've learned in Form 4, Form 5 Maths. Okay, so now substitute everything, or you cross multiply first, then substitute everything, the value, and nanometer, no need to convert to meter because cancel out, the nano tends to the power of -9 cancel out. 1 meter, and you get 1.50. You see, must larger. Your answer must larger than the original 1 meter. So the answer is D. Okay, so any problems or not? Okay, so if no problem, so just be careful with this question. They can give you if the DNA constant, like this animation, the wavelength change with the Y, wavelength change with the separation. Okay, so that's mean when the wavelength increases, the separation is increases. You see, the separation increases when the wavelength increases. Okay, another one, they might give you questions like this. Okay, so if you make constant wavelength and D, so same type of light, let's say red light, infrared for example, red light. So lambda constant and the distance here constant, screen and the slit. So that's mean the changes is between A and Y. So A and Y, so that's mean inversely proportional. So A increases, Y decreases. Okay, so you can see from this animation. So when A, this D is A lah. Some books use symbol D. So A increases, so the fringe increases. Okay, and the last one, they might give you lambda and A constant. So if lambda and A constant, so Y and D changes. So Y and D changes directly proportional. So D increases, so Y increases. So you see, as Y increases, okay, A remain the same. So you see the fringe here, distance, the separation fringe increases as the distance increases, right? Very simple relationship if you just use the formula. Okay, so I think that's all. Okay, thank you for watching. I give back to our moderator, Cikgu Non. Okay.
Okay, thank you, Madam Rosmaya. So, with God's grace, we have reached the end of today's lesson. Congratulations to those who are able to follow our lesson from the beginning till the end. So, before we end our session for today, I will announce two last digit code for the credit claim. Okay, please listen carefully. So, the last two digit code is number 9 and 6. 9 and 6. Okay?
6.
9 and 6. So all of you, please stop posting your comment for a while and click the subscribe button and activate the icon bell so that you will not miss the next class lesson. Then, if you find the lesson was beneficial, click like and share to your friends on your social media. Spread and share the goodness. Once complete, type done on the chat box before the certificate link is given as token of thank you for your dedication in joining the free online class today. Okay, so I will put the link for the certificate claim. Wait, and also for the credit link for the credit claim. Okay. Okay, very good, Chia Yao. Uh-huh. And wait, our presenter today. Okay, so please take note that the link will end half an hour after this live. Make sure that to use the EDD email or MOE email only to log in. So incorrect email use will not be entertained. So if you have any good haven't got one, please apply the link. Apply, and the link to apply the EDD email is already given in the chat box. So please refer to the chat box. If you wish to get more information on the online classes, you can go to the academyyoutuber.com, and to those who haven't joined EDD Junior Telegram, please do so. So once again, I would like to thank all students for joining today's class. You are very awesome. Feel free to share this free tuition class to your friends and teachers all over Malaysia. This is a collective effort from all teachers throughout Malaysia for all the students throughout the country. Thank you for being a YouTuber academic supporter too. So I think that's all for now. See you in the next lesson, which is at the same time, okay, and the same day, which is in Ramadan. So we will start at 3:30, right, Madam Rosmaya?
Yes.
With that, I will end our today's class. So please remember the hashtag bermula percuma and selamanya percuma. Assalamualaikum warahmatullahi wabarakatuh, and thank you.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.